Okay, so let's go ahead and take a look at an example here. Let's let f of x equal sine of 2x. And the question is to write the first three terms of the Taylor polynomial and show that the estimate of x equals 0.3 is off by less than 1,000th. So when we do something like this, first things first, let's look at our Taylor series expansion. Now we know that a Taylor expansion of sine of x in general is equal to the summation of n equals 0 to infinity, negative 1 to the n, x to the 2n plus 1, all over 2n plus 1 factorial. This is just a generalized one right here. It's an alternating series because we have the negative 1 right here. So if we were to write out the first three terms of this right here, we would simply get x minus x cubed over 3 factorial. Remember, the even terms go away because we're only dealing with 2 to the n plus 1, plus x to the 5th over 5 factorial. But it's important to note in this case we have a slight difference. We have sine of 2x rather than just sine of x. So everywhere we see an x, we're going to be thinking in terms of 2x. So this is going to become 2x minus, in parentheses, 2x cubed over 3 factorial plus 2x to the 5th over 5 factorial. Let's do a little simplifying here. 2x minus 2 to the 3rd power is 8. So I have 8x cubed, and 3 factorial is just 6. Plus here I have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. X to the 5th, all over 5 factorial. 5 times 4 is 20, 20 times 3 is 60, and 60 times 2 is 120. So let's do a little bit more simplifying here. This is going to be the same thing as 2x minus 4/3 x cubed. And if I were to try to simplify this a little, I can get dividing it by 4, for instance. 32 divided by 4 is 8. 120 divided by 4 is 30, so I have 8 out of 30. Dividing that by 2 again leads me to 4 out of 15. Looks like about as simple as I can get. 4 out of 15 x to the 5th. So these are the first three terms of my Taylor series polynomial, and I want to see what that looks like at 0.3. So I'm going to say 2 times 0.3 minus 4/3 0.3 to the 3rd power plus 4/15 0.3 to the 5th power.